Hi everyone! The goal of this video is to talk about secant and tangent lines and the angles formed from secant and tangent lines. Quick recap about what secant and tangent lines are. A secant line is a line that has two intersections with a circle. So it would cross through more than once, specifically twice, that's as many times as it can. It looks something like that. Whereas a tangent line would only have one intersection point with a circle. So it would just brush the circle, it would just touch it at one point. It would never cross through, no matter what you do. So like this would not be a tangent line, even though it only touches once. Eventually, if you extended this line, it would go through again. Okay, so purple is a secant line, and the pink is a tangent line. Okay, so now secant and a tangent angle are angles formed from secant and tangent lines. So a secant angle is an angle formed from two secant lines. Whereas a tangent angle is an angle formed by two tangent lines. Math is nice and logical. They give names that make sense, right? So we call it a secant angle because it's made from secant lines. We call it a tangent angle because it's made from tangent lines. Okay, so a secant angle, to give you an example, it could look something like this. So here's a secant line because it crosses through more than once. And here's another secant line because, again, it crosses through the circle twice or has two intersection points. So a secant angle could be this angle formed from those two secant lines. Could be this angle because it's also formed from the two secant lines. Could also be this angle, and it could also be this angle. Okay, another example of a secant line, this is inside the circle, but the secant angle could also be outside the circle. So I'm going to do that in like a darker purple. So let's say you have this secant line right here because it touches here and here, and you have this secant line that crosses through here and here, right? It's two secant lines here, but the angles are now outside the circle. So it could be here and here, okay, or this is also formed from the two secant lines. So keep in mind, secant angles can be inside or outside the circle, whereas tangent angles are formed from two tangent lines. And a tangent line just kind of brushes the circle, but it never crosses through. Looks something like this again. If I could draw a straight line. So a tangent angle is always going to be outside the circle because these lines don't ever go through the circle. Since a tangent line never goes through the circle, the angle will always be outside. So a tangent angle could look something like this. They're created from the two tangent lines here. So you could look at that first angle or the second angle here as an example. Okay, now that we're done with vocab, let's talk about the theorems about secant and tangent angles. We're going to start with secant angles first, and there are two different kinds of secant angles. So there's the inside secant angle, and there's the outside secant angle. I'm going to start with the inside secant angle. So just to kind of redraw that, it might look something like this. So these are two secant lines because it crosses a circle at two different points. So again, an example of an inside secant angle would be this angle here or that angle here. Okay, as we learned from our conversation about central and inscribed angles, in order to find the measure of an angle in a circle, you need to know something about its arc. So for example, this angle right here intercepts this arc right here, or that's its intercepted arc, because it has the same endpoints as that angle, and it's across from that angle. Okay, but these two lines intersect also make this angle, and we know these are vertical angles, so they're the same. So these two intersecting lines also form this arc right here. So really, secant and tangent angles have two arcs that they intercept, not just one. So both of these angles make both of these arcs that are highlighted. So we need a formula that not only relates one of the angles to the arc, but also relates both of them. So an inside secant angle is calculated by taking the measure of arc 1, so let's call this arc 1, this arc 2, it doesn't really matter. The measure of one of the arcs, and you have to add the measure of the other arc, I'll call that arc 2, and then you're going to divide it by 2. So the way I think about this is like you're averaging the size of these two arcs, so you add them up and divide by 2. Whereas an outside secant angle, well, let me draw one of those first so we can kind of see this. An outside secant angle might look like this angle right here. So it's created from two secant lines still, but it's outside the circle. So like these angles are outside the circle. Now, the arcs that intercept that here, well, one of them's right here because it's got the same endpoints as that secant line, and the other one's what it opens up to. So here's the other endpoint, and it goes all the way to this endpoint here. Okay, so again, this secant angle, even though it's outside the circle, it has two arcs that it creates. So one's right here, one's the other green arc. Now to find the measure of the outside secant angle, it's similar to the inside, except you're going to subtract the two arcs. So you're going to take the measure of arc 1 and subtract the measure of arc 2 and divide by 2. Okay, now if you think about this, arc 1 has to be the bigger arc because you can't have a negative measure for an angle. And if you took like 60 minus 100, you'd get a negative number. So we put the bigger arc as arc 1 and the smaller arc is arc 2. Now this one doesn't matter because you're adding them, but this one order does matter. Okay, now a tangent angle, there's only one kind of tangent angle. A tangent angle can only be outside the circle. So I'm actually going to write that. It's always outside the circle because tangent lines don't go through the circle. So how could the angle be inside the circle? Okay, so just to draw one of those tangent angles, I got to make it from two tangent lines. Tangent line would just touch the circle at one point. So here's an example of a tangent line. And here's another example of a tangent line. And brush the circle, just touch it once. Okay, so that couldn't possibly be inside because the tangent angle is never inside the circle. So here's an example of a tangent angle. It's created from two tangent lines. And a tangent angle, similar to an outside secant angle, is going to have two arcs that it intercepts. So if you look at this point on the tangent line, here's one of its arcs. But if we look at the other side of that point, it's got another intercepted arc over here. So it's also got like a big arc and a small arc. So an outside, or just a tangent angle, because they're always outside, is calculated the same way as an outside secant angle. So you're going to take the measure of arc 1, which has to be the bigger arc, subtract the measure of arc 2, it's got to be the smaller arc, and you're going to divide it by 2. Okay, so to summarize, really, instead of calling them secant and tangent angles, we can categorize them in two different ways. We can talk about angles that are inside the circle, and we can talk about angles that are outside the circle. So if an angle is inside, you're going to add the arcs. So you're going to take measure of arc 1, if I could spell arc 1, add the measure of arc 2, and you're averaging it, so you're going to divide by 2. Whereas if an angle is outside the circle, so a secant or a tangent angle that's outside of the circle, you're going to subtract the arcs. So measure of arc 1 minus the measure of arc 2, and you're going to divide it by 2. Okay, so that's just summarizing the points we talked about up here, because they can really be broken down in two ways, since this formula is the same as this formula for secant angles. Okay, let's try a couple examples. So they give you arc AB is 71, and they give you the measure of arc DC, which is over here, is 163. And they want to know the measure of APB. Now, something to note, again, these are vertical angles. So if you're finding APB, it's really the same thing as finding like DPC here, because those are the same. So this is an inside angle, because it's inside the circle. In an inside angle, you're going to add the arcs and divide by 2. So our two arcs are 163 plus 71, and you're going to divide that by 2. So plug that in your calculator, see what you get. If you've done it correctly, you should get 117. And remember, we're talking about angles, so that's in degrees. You have to always label what you're talking about. Okay, so that's an example of how you find an inside secant angle. Okay, number 2 gives you the measure of AD is 133. So that goes from A to D, which is this arc right here, is 133 degrees. And the measure of BC, which is right here, is 48 degrees. They want you to find the measure of APD. So going from A to P to D is that angle I've highlighted right here, which is outside of the circle. So it's all the way out here. Now for an outside angle, since we're referred to our notes, you're going to subtract the arcs and divide by 2. Okay, so my big arc is 133, my small arc is 48. Now if I do 48 minus 133, you're going to get a negative number. And can you have negative degrees? With what we know right now, no, you can't. So I always have to take my larger arc and subtract my smaller arc so I don't get a negative number. Plug that in your calculator and see what you get. Okay, you should get 42.5. It's okay to get a decimal. It's just like any other number. It's just a portion of a whole number. And don't forget your degrees, because we're talking about the measures of an angle. Okay, so this was an outside angle, but further, it was an outside secant angle because it's created from two secant lines. But it doesn't really matter if it's secant or tangent lines that construct the angle, you still calculate it the same way. So that is all I'm going to do in this video. I'd like you to think about trying these on your own, especially number 4. I'd like you to try number 4 on your own. When you're done, I'll come around and check it, and you can work on some more problems. Thanks for listening, and ask questions if you have them.